Hey everyone. So today we're going to talk about using Django to build our RESTful API. We've seen a RESTful API with the Rick and Morty API, with the Pokemon API. Now we're going to start seeing how to use all the really cool stuff that Django offers to build one ourselves with Django models, with Django views. We'll talk a bit more about what views are, and we'll use a bit more of Django REST framework and see how it really, to quote a movie, kind of like ties the room together and brings all the pieces together. I realized that yesterday, I ended up rushing a bit through the part of our lecture that talks more about Django server. So I thought a good way to get started here would be a brief review of creating some paths and view functions and just keeping it simple. So I figured I would build out a little bit of what we were looking at yesterday with our geometry functions. And I might ask for a little help from you all as we go. And let me grab my guide code that I want to use here. And so I have, just to orient everyone, we can ignore this project up here, but I have a Pokédex project, which is the one that we've been working on. And it has the Move Django app and the Pokemon app. But for now, we're just going to stay in the main project directory of this Django project. And I will just write our paths and actually just our logic and everything in the URLs PY of the main project. And then in a little bit, we'll come back to this include and the Pokemon app and sort of seeing like the proper way to organize things in Django. But just to review and go over this stuff, I wanted to do it this way. And again, I'll probably ask for a little bit of help as I go, both to kind of give the process a good flow and also liven things up. So can someone remind me, what does this, and we'll put that in comments, we'll put it maybe up here to come back to later. Can someone remind me, what does URLs PY do in Django? What does this URL patterns list do in Django? What does this path Django function that we call do? When I add path squares, what am I doing?
You're like setting up a route to like a different page or an app.
Yeah, exactly. I'm setting up a route so that when I make an HTTP request to the browser, or from the browser rather to the server, Django knows what to do when someone sends an HTTP GET request with that URL. And then in fact, I'm just going to write, I think, right up here, let's go ahead and just import. We saw a little bit yesterday, Django gives us an HTTP response class. And I'm going to write a function called square area view. And it's going to be really simple. Can someone actually remind me, what do those two stars do with each other again?
Is it like
An exponent?
Yeah, exponent.
Yeah, I think it's an exponent where we're squaring the number 2, right? Which is an area of a square where each side is 2. So this is super simple square to do, handle, squares with sides with lengths other than 2. And now that I've added this square area view function as the second argument to my path, can someone remind me what does that do now in our Django application? Well, with luck, what happens now is with my Django server running over here, if I go in the browser and I go to 127, so the Django server is running, but I'm getting an error for reasons not worth going into. But if instead I give it this path, Django says, hey, when I get an HTTP request where the route, this part of the URL date is squares, I know to send back 4. And in fact, I could even use something like curl on the command line, which sends an HTTP GET request. And if I just do this, it would be 2 127s. There would be the issue. Note that this is, I get the HTML from that Django page. But if I do squares, I should have gotten a response back. There we go. Sometimes Django is a little funny about leaving the trailing slash at the end of things, right? So whether it's the browser or another program to send the HTTP request, our Django server knows that this is when I get an HTTP request and this is the path and the URL, I should call this function to do stuff. And I just want to pause to see if folks have any questions or things that you'd like me to maybe touch on a bit more. And I know that we've seen this in other shapes and forms, no pun intended. So what I wanted to dig into a bit more was how to start passing parameters through as well. Because we saw that a little bit, but not a lot. And to kind of, I am gonna borrow some guide code from yesterday for, say, another view function to calculate the area of a circle. I do have to do a little bit of importing here. I just have to import the Python standard libraries math method for our circle area. Note that we're not doing anything with this request. Well, we weren't here, but we will do something with it here. And it'll be really interesting, I think, to see what gets printed with this request object. And so very similarly to React Router, I can add another route to my Django web server. And I think we should call this one circles. And we'll tell Django when you get an HTTP request where the path is circles, I want you to call this circle area view function. And I keep getting these errors as I go, but then no, Django is actually restarting the server every time I'm making a change, which is a really nice quality of life feature. I think I'll open up the network tab over here just so we can see it and watch what happens. So instead of squares, let's do circles. And we got a little more information here. I would have actually expected a bit more. I wonder if I have a typo or I'm doing something wrong. Let's see here. The request object has a number of things, maybe query, grams. No, I'll go down that bridge later. We'll see more of what to do with this request object. I don't want to get too lost in that right now. But what we'll see later is when we start passing data, we can grab it from here. And that's the other thing I want to show a little bit as well. Specifically with triangles. And again, this is I'm drawing from the lesson yesterday, where because of the time crunch, I did rush through a bit of this stuff, so I just want to kind of review and go over it again. So just like with React Router, with our routing, we could have as many slashes as we want in here in the path. And Django handles all of that fine. Where it starts to get interesting with Django is when we start to use these angle brackets, because this is something special where we basically can put a variable in our path and we're not giving Django just a string, we're really giving it a pattern. And it's a pattern that it's going to match. And this pattern says, Django, the path is squares, it is circles, it is triangles slash height slash some integer. And so what we see here is, and can everyone, is this font size okay for everyone? Inside these angle brackets, the first bit before the semicolon here is the type of variable, and that helps Django really convert it when it builds up this request object for us that we're going to see. This is actually the variable name that Django is going to use for us, and it's going to create it. So we're telling Django this pattern, this is sort of like a regex is, it'll be triangles slash height slash something, and that something you will turn into an integer and assign to a variable named height. And after that, the pattern will have the word base, and then there will be another something that you will assign to an integer, or cast into an integer and assign to a variable named base. And now we do need to write this triangle area view function. And I recommend, the way I recommend building out your view functions is start with something really simple and build it out from there, right? So I just want to make sure that I got this right. And triangles does not work, right? Triangles slash height does not work. Triangles height slash 5 does not work. But height slash 5 slash base slash 3 I may have a typo. It says triangle area view got an unexpected keyword argument height. So I think there's two possible issues in here. It may be my view function. I don't think it is actually the path. Let's build up our triangle area view function and find out. So I suspect I may have simply forgotten a step here. What happens if we add height and try this again? Well, this is good news. Our unexpected keyword argument changed from height to base. And now if I add base, and try this again, now those errors go away. And so what those errors were telling me was Django says, hey, cool, you've given me this function to call on this path. But Adam, your function definition only takes one argument for the request object. And I'm a little confused because you also told me when you defined this route that I should take part of it and turn it into a variable named height and a variable named base. And I really want to pass those as arguments into your function, but your function does not have enough arguments for me to do that. And I want to pause and see if folks have any questions there. So I think this is an easy gotcha. And also this is where we start to get to the good stuff. And I'll try to keep an eye if folks have hands up, but I have a couple screens open now. So if I miss something, please just shout it out, put it in the chat.
I don't know if I missed something. Where's the 5 and the 3 come from?
Oh, these numbers here and here?
Yes.
Oh, why are those numbers even there to begin with?
Yeah.
Yeah, great question. So over here in the path, basically what we're looking at now, and the question is always, how do I send data from the client to the server? How do I send data from the browser to the Django server program? And there's a bunch of different strategies. And again, to illustrate, like we don't have to do this just in the browser. If you want to use curl on the command line to send an HTTP request, right? I can, or this tool postman that we've talked about a little bit. I just believe this would be triangle / height / bar / let's just do that. Oh, and I see what's going on here. Apparently I'm not getting my print statements. Interesting. I'll kind of cross that bridge in a minute. So the question is always, how do we send data from the client to the server? And there's basically, if we step back, big picture, there's two ways. We put the data in the URL. And that's what we're doing here, where these parts of the URL actually hold data. If you think about, Rick and Morty, characters, Rick, we're actually sending data to the Rick and Morty API in our URL in the HTTP request that we send. You also all have seen this other approach with what's called a query parameter, where maybe it looks something like this. And I don't know, limit or page equals 2. Or there should be an equal sign there, excuse me. This is another way to send data from the client to the server in a URL. The other way is to put it in the body of an HTTP request where it's not in the URL at all. So just for learning purposes, what I'm doing here is I'm sending the server information about my triangle, its height and its base, and I've formatted the way I've designed this URL, this endpoint. The height is at this point in the URL that the server is expecting to receive, and the base is at this point. Does that help, Cody?
Yep, thank you.
Awesome. Yeah, great question. And I'm a little unsure. Normally, I expect to see these print statements when these view functions get run, and for some reason, Django doesn't seem to be printing it out at all. So I might poke around at that in a moment. But what we can clearly do Oh, Halsey, thank you so much. I'm so sorry, Cody and Halsey. I apologize about that. And guys, thank you for mentioning that in the chat.
No problem.
Forgive me. I clearly need to drink more coffee. I'll solve the mystery of why my print statements aren't showing up there in a moment. For now, let's just calculate our triangle area. I'm not gonna lie. I knew a decent amount of math. I've forgotten a lot. I'm taking it on faith that that is a reasonable formula for the area of a triangle. But now we get to the fun part of we just created an API endpoint where we can pass data in our URL. The server does work in the view function and sends back a response with data for the client to render, right? You all have learned how to write very rich and powerful React applications to interact with API servers like this. And now you're learning how to build the API server backend for your own React app to be full stack. And let me see if I can't figure out real quick why the print statements aren't printing.
Aren't those it in your console?
Oh, they are there. I'm so sorry. I feel like I'm losing my mind, or what's more likely, maybe I just needed to kill and restart the server. Let's see what happens if we do /circle. I guess it is there. We see this whole object that we can dig into later. But the more important bit here is what we see printed here, 5 and 3, is coming from these two print statements here. So just to reiterate, when we define a route and we want to let parts of those route be dynamic, be defined by the user, so the user can pass us data, so our client can pass us data, we use angle brackets. And on the left of the colon, we say, Django, you're going to create a variable of this type. On the right of the colon, we say, Django, here's the variable name. And then we do have to make sure that the view function has both of those variable names. Otherwise, we do see an error. And so if you see, and this is a common mistake to make, I made it earlier. If you see this error in the browser when you're developing with Django, that one of your view functions got an unexpected keyword argument, that's a fancy way of saying, well, the keyword argument was something from the path that Django is passing in, but the function does not have an argument to receive. So double check your path versus the arguments of the view function. And I just want to see if folks have any questions about that. Cool. Lastly, what we can also do with Django paths is pass a property name. And this makes it easier to refer to these paths in other places in our code. So it will not break anything right now not to use them. It is a good habit. And we won't see it right away, but it lets us like way more easily refer to, say, this specific path if we want to. We could do like, URLs dot triangle, for example, somewhere else in our code. So that's I just wanted to review and go over that stuff from yesterday a bit more before we dive more into really the meat of today's lecture, which is about building on this. I previewed it a little bit yesterday with include and using Django REST framework and classes to basically, instead of this, Django REST framework gives us these model serializers. We've got models. We're going to be able to plug all these things in and write a class and have it do a whole lot of this work, and it's going to be awesome. So why don't we take a break? Do folks have any questions or points maybe that it'd be useful to go over again with this before we break?
I have a question, but we can save it for during the break. I just wanted to know what your views file looked like.
Oh, great question. I did not put anything at all in my views file, and I did that on purpose. Normally I would put these in a views file and then we would just import them the way we you actually can see the example here from yesterday's example. The same way you would import a function from any other file in Python. And that is the way that we should organize it, but Django won't freak out if we do it this way. And so for prototyping, if you find it easier to build up some of your view functions here, you totally can. Though, especially with Django REST framework, I think it'll be easier to just put these in views right off the bat. But we're going to see that next. Just to very quickly demo that refactor, because you do raise a good point. And Andrew's point is, hey, this is cool, but I remember we saw this views file yesterday, Adam, because you kind of jumped ahead. So what's the story there? And so now that we've prototyped this, we might want to move these into our views file. And I'm going to leave them here so that they're in the demo code for learning purposes. But I'll just show you what it would look like. So for this one, just as an example, right, I would have this in the views file, and I would just do from .views import square area view. Does that help a bit, Andrew?
Yes, it does. Thank you.
Yeah, totally. Thank you for asking that question. That was a good point. All right, why don't we take, how does let me actually pause the recording. So we're gonna now learn how to use the Django server to build our own APIs, and specifically what's called like a REST API or a RESTful API. And very, very briefly, very, very, very briefly, we will talk more later about REST APIs. REST is an acronym that stands for representational state transfer. Here we go. In this Smashing Magazine, they have the CSS tricks article, and now they've got the REST APIs article. This is, you all have heard those terms, by the way. I'm more than happy to talk about representational state transfer and all this stuff another day. I just want you to know that REST is an acronym. This sort of architecture was actually some guy's PhD thesis in like the late 90s. You'll hear these terms like endpoints, HTTP headers, and stuff like this. And basically what this does is solve the problem of, like, it's 1992. Awesome. We have the internet. We have browsers. We have URLs. Stuff is starting to become more complex. How do I organize it? Right. And again, just to very, very briefly touch on this, the essence of all of this stuff is a set of rules of how we should design an API like we are now. And a lot of those rules are about the URLs that I want to have Pokemon / name or trainer / Pokemon. And you see these all over the internet. And basically, it's sort of this abstraction of let's think about how we can use URLs to represent resources, which is kind of another word for entities. And I don't want to get too much into it now. I'm happy to talk more about it later. And we're just going to start digging into the surface of this. And a lot of this you've actually seen. And so to recap, the flow is we've got our web application. It sends HTTP requests to our web server, which is Django, which talks to our database, which is Postgres. The Django web server sends an HTTP response back. And this RESTful API is sort of more abstract. It really represents what we've built here on the server. And it sends it back to our web app. So let me ask a question. For this server that we built, this web server and this API that has these endpoints, these routes, admin, squares, circles, triangles, with all this extra stuff. Pretending that this Django server was, running on some other computer that was available publicly over the internet. So it wasn't just local to my machine. Could I use my phone to hit these same endpoints to get the area of a triangle?
Yeah.
Yeah,
Yeah.
not a trick question. I know it may have been a little too straightforward. Yeah, absolutely. The client can be a phone. I could use my browser. Could we write a Python program to talk to our Django web server and get the area of a triangle? And the answer to this is absolutely yes as well. We can write Python programs to send and receive HTTP requests. This idea of a client, right? And in fact, here, using this little command line program curl, for all intents and purposes, we could have written this program curl in Python. It's not, it's probably written in C or something, but we can write a program to send and receive HTTP requests, and that's all a client is. A browser is just a super fancy, awesome client with a whole lot of graphics, plus HTML, plus JavaScript, and so on. And if you think about, say, these really rich web apps that we use, they all have the common requirement of they need to get data. When you go to Facebook, you need to get data. You need to get the most recent posts. Or you go to Instagram, that feed, that data lives on a database somewhere in the cloud. Someone has written, maybe in Django. Twitter was actually, I think, built with Ruby on Rails and used it for a really long time. And Ruby on Rails is very similar to Django, but for the language Ruby. When we go to Instagram on our phone with the app in the browser, the beauty of endpoints and API servers is they don't care about the client. As long as it can send an HTTP request, we can give it data. And so Instagram's Django server has to talk to its Postgres database to get all that information. And so under the hood, and you can see this if you go to Facebook and open up the network tab in the browser, which I would love to do, but in the interest of time, I'm not going to do right now. But you can go to Facebook, you can go to Google Maps, any website where, there's new data coming in. If you open the network tab and look, you can see the HTTP requests that it's making. And you all know this because you built this with your Rick and Morty apps with React. And the URLs look something like this, where we have the protocol HTTP, the domain, and let me get my annotator rolling here. the protocol, the domain, or the IP address, right? We're using 127.0.0.1 for localhost. And then this is where the REST API conventions and rules start to come in. And nothing breaks if you don't use these rules, but this is how pretty much everyone designs APIs now. You'll be expected to kind of know this for technical interviews. And also the beauty of this is, as you all experienced with a little bit with the Rick and Morty and the Pokemon APIs, is that with this standard approach, we can write other software that can easily use these APIs and these URLs. It's almost like our interface. It's like the order of the phone book in a lot of ways. And we start with /API because we might need to send CSS files and stuff, and those go on other routes that don't start with API. And we can tell Django server to, if it's not API, go somewhere else. We'll usually start with a version, because imagine we've built an awesome API and thousands of websites all across the internet, and tons of people use it in their apps. And we make a change to our code and we change the structure of some of the URLs. Well, suddenly all this code breaks because it's expecting to use these URLs that look a certain way. So by having version 1 and version 2 and so on in the URL, I can do, this is, I apologize, let me use the type feature here. Maybe V2 is user posts. It's no longer just posts. We have to start with the user. But because we have V2, everyone else can still use the V1 API, and we won't, take it down for like a year or two. So this gives us a lot of flexibility. And then we'll see very much like entities that we talked about earlier. This is where we start to care about the things that our data represents. So that's sort of like a quick overview of APIs. We've talked a bit about web servers. And the thing to remember, again, is a lot of the times when I say web server, I mean Django. I mean a program that's running, that's listening for HTTP requests and sends back responses. Sometimes we'll be talking about the server and we're talking about like the physical machine that this web server program is running on. We've talked a lot about databases. We've seen a little bit about HTTP requests, excuse me. We'll talk more about these different HTTP verbs later. There's a bunch of rules around how to use them. But basically, let's actually do it this way. Let's do it over here. I apologize. Here we go. Create, post, read, get, update, put, delete, or destroy, delete. So we'll see these HTTP verbs in Appchain, but when we talk about post requests, get requests, the reason is the convention when we're building a REST API is get requests are for reading data, post requests are for creating new data, put requests are for updating existing data, and delete requests are for, well, deleting it. And again, this is more informational. We will dig more into this later. What I do want to get started on is, first of all, clearing these annotations. And second of all, writing some code, though the annotations are giving me a little trouble here at the moment. There we go. And just to kind of recap, the flow that you all have been doing and that we are now building this Django web server for is our web app sends a request. And I'm going to bring back the annotator here. And our Django web server is our API. The server talks to the database to get all the user posts, right? And so maybe this is, in fact, this get is get posts. And by default, in a REST API, if we just have like the resource that we care about, it'll get all of them. So Reese, yes, what's up?
Well, I guess I've been trying to connect the dots in my head, and I just wanted to know if I was understanding it right. Like,
Awesome.
because we have our React, and that has its own set of URLs, and then we have our Django API that has its own set of URLs, and so we're just never actually connecting the two, but using Axios to get the URLs from the Django API to connect it in our React app.
Yeah, you are correct. React and single page apps are a little bit of like sort of a zombie Frankenstein. Because like you're saying with React Router, we kind of take over that browser URL bar with React, and React actually drives what goes in there. And those front end routes for React are really just for React, as you pointed out. And then, like you were saying with Axios, that's where we use the routes that we build here with our Django API server. So there are these two separate sets of routes. Now there's probably going to be a lot of similarities. Like if I want to see a list of all posts in my React app, I'll probably create a React router route posts, but that's just for React. That's just for user navigation, and that's just for the front end. In my Django API, I'll have a whole bunch of routes, and one of them will also be posts, but the way I use that is with Axios and Fetch, like you were saying. And it didn't used to be this way. Like it used to be, you know, if you weren't using React with the browser, what you put in the URL, that got sent to the server, and these things really did line up. But then single page apps, and like React, like what we can build with React came on the stage and kind of blew that up. And now front-end routing is sort of like a weird Frankenstein, and it is a little confusing. So you're correct. There are these two separate things. It's for our REST API, it's Axios. It's what we're doing with Axios to make those like get requests with our JavaScript code is where we interact with our server's API. I know I went down a little bit of a rabbit hole there. Does that help a little bit?
Yes.
Awesome. And I think this is one of the challenges with this stuff. There's definitely a lot of moving parts. Remind me, and I will come back later, I think, with a good illustration of sort of like what some front-end routes look like with React, and then our Django REST API routes. But you absolutely have the right idea. The front-end routes don't have to match up to the API routes at all. And all of the routes we create with React Router, potentially we never ever have them send them to like Django at all. What other questions do folks have kind of around this flow of the GET request? And then React, of course, would be living over here with React. And I apologize that this is absolutely terrible. That's not very helpful. Let's go ahead and let's take a look at writing some code to start building this out. And I'll follow up later with, I think, a diagram kind of showing some React routes and stuff. And as we start building out these server routes, this REST API for our Django app, I think it'll help visualize to how these pieces connect. So this is a really good transition, because as you all know from working with React, when you're working with a third-party API these days, what we usually expect to get is JSON, right? And right now I have these functions, these view functions, and they're not really returning JSON. And that's actually really our next step here. And this term view very briefly, let's see, where are my shapes? Maybe we'll put that there, and we'll put this there for model, and we'll put this here for the controller. So if we go back in time like 10 years, before React and single page apps, and we were writing Django, we learned Django models just like we did. Django sort of combines these two things together into what it calls view functions. But what we would have also learned is, like, in our Python code in Django, how to like create these HTML templates. And traditionally, there's this sort of architecture called model view controller. And you all have, I think, are really familiar with the model part. And that's pretty much what it sounds like with everything we've learned. Traditionally, the view was HTML that we stick our data into and that the server sends to the client. And the controller was a lot like what we had here. So we might have this circle area or this triangle area. In other frameworks, it's called a controller function. But then it would construct an HTML page and send it back to the browser. And that would be our view. And these three things of model, view, controller. Again, single page apps have blown this up because now, today, the view is our front end React app. It's not in Django at all in a lot of ways, but this term view remains, and that's sort of the context for how we are using it. And let me clear this. And sort of with that preamble, we can start talking about Django REST framework and Django API views. So we know that, excuse me, let me make the annotations go away. So we know that the order of these URLs matter, and that it's actually like the order and structure of these that are like critically important when we're designing our server-side REST API. And so for our Pokemon app, and I'll get rid of this one here because we're not going to use it anymore. And I think what I'll do is I'll just do some visual white space here so we can see it a little more clearly. For our Pokemon app, let's build a REST API. Let's use this proper structure. We definitely want to start with API so we can separate it from paths that are going to send back CSS. We want a version. So when we change our API, the thousands of people using our Pokemon API, their websites and apps don't break. And we want the resource or the entity that we care about. This is the path that we're going to use for everything Pokemon related in our API. And to do this, I don't want to have to write out all the import all my functions here and do this work. I want to be able to use Django apps. I want to be able to have my ice cream organized by flavor in different ice cream containers in the freezer. So we have to use this method that Django includes, named include, and we give it the name of our Django app and .urls to tell it, go get the URLs module, which really means go look at the URLs py file, which that is the URLs module, because files are modules. So I think I need to, I already imported includes. So that is an important step here, that if I didn't have this here, I would have to import includes, and it comes from Django.urls in the core library. And the next step is, well, my Pokemon app has a urls.py file because I made this yesterday when sort of exploring this at the end of class. But if it wasn't there, I would have to create it. And I just right click new file or do it in the command line. This urls py does have to be inside our Django app directory. And actually, let me go ahead and do a split so we can start seeing both of these things. So we've got this piece down and this piece down. And I sort of had shown a little bit of doing Pokemon Hello World with the Hello World method. But we can come back to, I'll just, I think, leave that there as, well, actually, we want to get rid of this because I think we do want our root path here to give us all of the Pokemon. So now, remember, I could do this, right, and return HTTP response. Yada, yada, yada. We saw just the same way I did here. But I do want to put this in a views py file. And we are going to do a bit more with it. And so just to reiterate, this method doesn't exist yet. But what I've done in this main URL patterns is I've created this new route. And let's see, why does it not like include? Include is not defined. It would be includes and not include, which is an incredibly easy mistake to make. So that is a very good one to keep an eye out for. But I'm telling Django, hey, when you get this route, go look at this other URLs py. There's going to be more stuff to look at, right? And eventually we might want, you know, path moves, right? And then this would be API v1 Pokemon moves. And this is API v1 Pokemon, right? Because we're including this over here. So we're constructing a full path this way because it gives us a lot of flexibility. So really our next step here is we do want to create our view function and start using Django REST framework for this. And we
Wait,
do,
so
yes, please.
real quick before you move out, I think that correct import for it is include, not includes. If you look down, you're getting an error about the imports there.
Oh, I got it wrong both ways. Okay,
So I think it's include. Yes, sir.
that is a great catch. I totally got tunnel vision there. Thank you very much. Let me fix that right now. Yeah, that is a great catch. That absolutely is an import error. It cannot import name includes because includes does not exist. And in fact, I could have realized this from this error message because the import worked fine, but this name doesn't exist. I read this error message backward and jumped the gun and fixed the wrong thing. But if I had taken the time, I would have realized that, hey, the import worked because it didn't throw an error there. And now we're getting an expected all Pokemon is not defined. And I think I will go ahead and open up the view and add something there just to make that error go away. And I don't want, is it useful for folks for me to like have 3 of these open, or is that starting to be a little too much?
That's fine.
Okay. And I can get rid of this sidebar as well if people don't want or need that, though I generally try to leave that open. So we have all these different functions here. Here is my Pokemon Hello World from yesterday. Let's just do def all Pokemon request return HTTP response all Poke. And again, I think this is a great way to scaffold your code. And I do need to import now from the views module. I need to import the all Pokemon method I created so we can use it. Even though this doesn't do anything yet, now my code is in a working state and I can get useful error messages as I develop, right? Instead of getting the error message about the thing that I haven't built yet, I built my skeleton and it all works and we can build on that. Very quickly, I just want to show where we want to end up here. This should look familiar from working with the Rick and Morty API and the Pokemon API and working with REST APIs that send back JSON. And now we are going to do this as well. So we're going to learn how to construct, it's called an API view in Django REST framework terms. We're going to write a class that uses our serializers and our models, and we'll send back to the browser, to the client, a JSON object. It's going to have a property Pokemon. And this is really common where the response JSON, right? The body of the response, the JSON and the response is an object, and it's got a property, and it's sort of a placeholder property. And then all the stuff we really care about is inside it. And you all have seen it with response.data and all these other patterns. And it's a pretty common approach because it lets us add like metadata and other important stuff in at the top level as well. So this is what we want to end up with, though I don't think I have EV in or Blastoise really or Charizard in the database. So we'll get however many Pokemon we have, but we want not just the Pokemon, but we also want their moves. And I did borrow to jump code a little bit in my Pokemon Django app. I did add a Pokemon serializer. I believe this was from maybe Tuesday's lesson 2 days ago. I might not have. I know we built the moves serializer. I'm not sure if we built this one during class. And so just to show this and also reiterate a bit of what serializers are doing, we're using Django's model serializer class. We do have to tell it what Django model we're going to serialize and the fields that we care about. And then because there is a many-to-many relationship between a Pokemon and their moves, between those two models, we need to write a method to deal with that and print that out. And the purpose of a serializer, remember, is to take data that's in an object and turn it into JSON, or take JSON and turn it into one of our model objects, to turn raw JSON into a Pokemon or a move, or take a Pokemon. We get our data from the database, we create our Pokemon model object, and I want to spit out some JSON so I can send it to the browser. And that's what a serializer does. And so get moves queries the database to get all the moves for this Pokemon using the Django models querying that we've seen. And this instance variable is a special variable for the Pokemon that we care about. It's sort of similar yesterday to how we saw self, but it's not the Pokemon serializer, it's the Pokemon, it's Pikachu, right? Pikachu.moves.all. And then from here, we're iterating through the moves and we're getting a list of move names and we're returning that list. And so now we have access to this method on our serializer that we can use as needed, and that the serializer itself can leverage if it wants to. So just to do a little recapping there. Let me go ahead and focus a bit on our view code. And then once we build out our API view, we can return and kind of see the routing and the URLs and stuff again. So we're in the Pokemon Django app and we're in its views PY file. And now we get to do the fun stuff. So I'm going to need my Pokemon serializer. And what I'm going to do is I'm going to build this up a little bit without Django REST framework so we can see sort of what it looks like. And then bring in the heavy hitter Django REST framework. And it looks like I may have a name wrong. No, that
I
name.
think you just forgot that import.
Oh my God. Thank you so much. There we go. So I'll leave Pokemon serializer off to the side here, so folks can look at it if they want to. So just like Django's HTTP method gives us this useful HTTP response, in all these classes, it's all about turning data into objects, right? I get data, but because I'm in Django land and we're object oriented, I really want like instances of classes. I want objects I can work with. I want to turn the raw data of an HTTP request into an instance of the HTTP request class. So we have some nice useful methods. Same for HTTP response. Same for JSON response. And this comes from Django. And so we don't need to do that anymore. We can get our actual Pokemon data. And here, let's in fact pass it a couple arguments. The first one we pass is a query. In fact, really what I could do is all Poke by name. Whoops, that was absolutely not what I wanted. I apologize. All Pokemon by name is Pokemon objects, right? So we're working with our Pokemon model here. And just like we've done Pokemon objects all, and that's a Django model method to query to get all the Pokemon that we've saved into our database and turn them into instances of our Pokemon model. Let's instead, I don't think we need the all here. I have to double check to make sure that I'm using order by correctly. But I think this is giving us all Pokemon ordered by name. I hopefully did not get the syntax wrong here. We'll find out in just a minute. I could use the Django console to check, but we'll discover this momentarily when we run our code. And I'm also going to pass the Pokemon serializer an argument that many equals true. And I believe we are letting the Pokemon serializer here know that there's multiple Pokemon to serialize, basically. We could check the docs to be sure, but you know, this argument name is pretty descriptive in and of itself. And just for fun, I think I'm going to print an F string, all Pokemon by name. And we'll do that. And in fact, well, we don't even need this because Django actually gives us a nice print statement when these view functions get called. And I think I'll print another F string, serialized Pokemon. And I believe it's Pokemon, and I want to say it's like Pokemon.data or something like that with the serializer. We'll see if I got that wrong in just a minute. And now let's use JSON response is an HTTP response that has JSON in the body of the response. And we're going to build our response JSON right here. Or rather our response dictionary. And so in fact, let's go ahead and do this. Let's call it maybe serialized Pokemon dictionary. And let's print that, right? And I do need to make that an F string. And now here, I'll just return this here. So you absolutely could write this out in line. It's just a Python dictionary if you prefer. I'm sort of doing this for learning purposes, and hopefully, is it useful having it sort of written out this way for folks that's the intent? I hope that's the case. But if this is actually more helpful than confusing, please let me know. And I'm just going to use autocomplete to help me spell this correctly. So we're just using the pieces that we've seen. The serializer with the model, a JSON response, which is an HTTP response that takes a dictionary that's going to be serialized, turned into JSON and sent back to the browser. And I added some extra steps for print statements so we can kind of watch this happen. So let's see what happens now. If I go to API/v1/Pokemon, and fingers crossed, it will work. I'm going to go ahead and clear the Django console there so we get good data when we make our request. And we want to go to 127.0.0.1.8,000 API v1 Pokemon. And in fact, let me open up the network tab as well so we can watch this in action. And I just need to get the Zoom annotation tools out of my way. I apologize. So whenever I'm testing something, I do like to clear all the consoles so that when I get the data, I know it's just for what I'm working on. And this is awesome. I got the data back. If we look here, we see that I get my print statements of all Pokemon by name. You know, that's a query set, which we've seen with Django models. So we have to, you know, call a query method to get the data, but we see what we're used to seeing from Django console. We see the serializer in action, right? It's created this dictionary of Pokemon data that's ordered. And then this JSON response class takes that serialized data, that it does the work of turning it into like the actual JSON text in the HTTP response, and then we see it over here. And if I look in my network tab, I can see the whole Megillah, where the browser sent an HTTP request to here, right, to this route. There was a GET request. The server sent back exactly what we wanted. Now I have multiple Pikachus and, you know, my data's messy, but that's beside the point. We now have our own Pokemon REST API, which hopefully should be pretty cool. The next step is to see how we can use Django REST API to make this a lot easier. Before doing that, I want to pause and see what questions people have. Okay, and should we take a short break before we bring Django REST framework into the picture?
Yes.
All right, let's do it. So we saw how to use what Django gives us along with the serializer to write an endpoint to send back data. And Francisco, Megan had a great question, and Francisco, thank you for answering it. And I actually need to dig a bit more into Django REST framework because I should have known this, but just to very quickly touch on this Pokemon serializer and this get moves. There was a great question about, well, how does the Pokemon serializer know to use when to use this get moves function? And if I understand correctly, the link here is that here we create sort of a special serializer field that just exists on the serializer, which this method name sort of hints at, serializer method field, a read-only field that gets its representation, its data, from calling a method on the serializer class. The method called will be of the form get underscore field name. So serializer does a little magic of it will look for a method named get moves. And then here's where we interact with the model to get the actual data. So, and Megan, thank you for using this as an example. If I wanted to have my serializer return a field named all moves, I would do something like this, where I rename the special serializer method. And this needs to be get all moves, because the serializer looks for a method starting with get, and then the name of this special serializer field. And then I need to tell my serializer, include this special serializer field. And the value of this is the model can focus on how we want to organize our data schema. The serializer can focus on how we organize the data for the user, for React, and all that other good stuff. So I just wanted to briefly, without going down too big a rabbit hole, briefly touch on that. What we are going to do next is, I think, really the good part. So we've got this view, and let me split this because what I want to show is our URLs py. And I've added a couple extra steps here, really for again, really for learning purposes, just to make each step really explicit, but you can condense this into about 3 lines. We've written this route, all Pokemon, or excuse me, the route is API/v1/Pokemon, and kind of show it all the way. We'll close out the serializer for a minute. We'll look at the other URLs PY just to kind of refresh ourselves here. I believe it is that one. If I go all the way down here, we've got API v1 Pokemon. And that connects to this. And that calls our all Pokemon view function. We want to do the same thing for some Pokemon moves now. And we're going to use Django REST serializer to make our life easier. So at the top level of our routing, let's add another path. It has to start with /API and it has to have v1. Otherwise, all software engineers everywhere will let out a cry of pain. And it's for the moves resource. And we want to get all the different moves. And we are going to include from our moves app its URL patterns. Now, I don't believe we created that. And remember, when you create a new Django app, it doesn't have a URLs PY by default. So the easiest thing to do a lot of the times is, again, I normally discourage copying and pasting. This is a time when it's not the worst idea to use some guide code as long as you remember to really delete all this stuff that you don't need. And really here, I am in fact going to delete all this stuff and just say URLs routing for Pokemon app. And let's create a URLs PY for our move app. And let's put this here and let's change this so it's for the move app. Note that we have no view functions to import yet. So I'm just going to delete this and I'm going to leave this blank for the moment. Though I think I will give it maybe a name. And we will build this up momentarily. And our API view needs to go right in there. So right now this doesn't quite work. The path is busted. But this part at least works where our top level routing is good because now this exists. So let me close this out for the moment so we can focus on building the API view. And let's actually build the API view for our move route. And here we are going to use Django REST framework. And so I want to go to moves app. Views in the move app. I always get confused with the singular and plural. And we need to import a couple things here. We need to import our model. And this is the Pokemon move. And just as a quick refresher, this is our Pokemon move model of the move's name, accuracy, and so on. And we're going to be using that. We're also going to be using the serializer rewrote for that. And as a quick refresher on that, remember we used Django REST framework serializer. And as I was saying, when we have like these relationships between our models, we need to really write the logic. And so we create this, oh no, I'm sorry, we're not actually linking that up here. I apologize. This is a bit of extra work that we have. This was actually from before, and we don't really need it here, so I will remove it for the time being. And this was a helper, but we never actually connected the dots to get all the Pokemon. And we might come back to that later, but for now it's not critical. We can at least start by getting our list of moves. So I'll just leave a note here. To do hook this up with serializer field. Like in the Pokemon serializer. Let's build the API view. We're gonna need some classes from Django REST framework. We'll need their API view and their response class. And now, instead of a function, we're going to write a class. And it's going to inherit from Django REST Framework's API view class. And what we need to do is handle an HTTP GET request. And then if we wanted to, we would write different methods to handle a GET request or a POST request or so and so on. And we need to name this method GET. And we need to pass in the object representing the HTTP request that Django will feed in here. And now we're going to use the model serializer. And we're going to get back that Python dictionary that we're going to turn into JSON. And we need to tell the serializer that we can expect many results, which I believe is what that many argument is doing. And we're going to use not Django's built-in response, but Django REST framework's response, which, as it hints at saying an HTTP response, it's using the Django response under the hood and adding a couple extra things that make it more flexible. And now, with luck, we're going to get back some data about our Pokemon moves. The last thing I need to do is import it and hook it up. And I may have a typo. Let's see here. The autocomplete is telling me I may have a typo somewhere, but let's write this out and then we can see what's going on. Let's give our route a name. Let me make sure that everything is working here. I'll add a little doc string. And now when I hover over it, okay, so I'm indeed importing the right thing. We're good to go. And the last thing we need to do is, because this is a class and there's a lot of different ways to use this, we want to use a method called asView that Django REST Framework gives us with this API view class. And there's a couple things that this does. It's not worth going into too much. The most important piece here is it's going to send back an HTTP response, and that will contain the JSON about our Pokemon. And it looks like I have a typo here that I have missed. It says module not found, no module moves app. So my guess is this is in the main URLs PY. I probably did plural moves app instead of singular. And if I scroll up to see where this error is coming from, and I'll make this a bit bigger so we can see that. I pretty much know where this is coming from, so I'm just going to dive in and fix it. If we go to our Pokédex project and URLs PY, I go down here, lo and behold, it's moves app. And I knew that because that's like one of the few places where I'm typing the name of the app. Sometimes with Django server, it's pretty good about restarting and working after an error, but especially with imports, sometimes it just can't. So you do have to kill and restart it. And things do appear to be working. So let's have our fingers crossed. What we've done now is this is not API/v1/Pokemon. This is API/v1/moves. Let's see how we do. Let me open up the network tab and clear it, and let's watch this in action. And this is really cool. And actually, I think there may be a step here that I need to do with Django REST framework, because as cool as this is, what I wanted to get back was some JSON. Actually, Francisco, do you happen to still be lurking?
Yes, I'm right here.
Is this what we expect with Django framework because Django is in dev mode, or is there a step that I missed here?
No, that's what you should expect. So it's giving you the JSON data within the body here.
Yeah.
This is just a nice display
Yep.
of what's going on. So it's showing you the HTTP status code. The GET request is what was sent. And then it can show you, yeah, you could break it down if you want to. But
Yeah.
essentially, it's just to show you a nicer format of your data.
This is awesome. Do you happen to know, like, if we turn off like dev debug mode in Django, does this go away and do we just get the JSON back?
Yes, it goes away.
Yeah, I figured as much. Okay, awesome. And actually, while we're chatting about this, then if I'm writing a React app, do I need to add an extra step, or does JSON REST framework, it knows when it's getting an AJAX request and it just sends back the JSON, and just when it gets the request from the browser, it's giving us this extra niceness?
It's just when it's getting the request from the browser that it's giving you this extra niceness. Otherwise, it's just returning the JSON data.
Perfect. Thank you. I can never remember exactly how that mechanism works, but folks, that is definitely a thing that happens where basically, like, you can dig into the body of an HTTP request if we go in here and like look in the headers, and it's maybe in like every HTTP request passes information about the thing sending the request. I think it's called like the agent. So we don't see it here right off the bat in the network tab, but every request will include like the browser and the browser version and stuff. And so sometimes, like here, the server recognizes that, and if it knows a browser is making the request, it sends back something slightly different than if it's just, say, some JavaScript running inside the browser. So this is awesome, to be honest, and this is one of the really nice things about Django REST framework is we do get this nice view. If we were making an AJAX call to this same endpoint, we would just get the JavaScript back. And in fact, I can do that right now just with curl on the command line. Just to demo this, so you all can see API v1 moves. And it probably wants the slash at the end because of Django's weirdness. And so when I use curl, or if we used Axios inside React, we would just get back our JSON. When the HTTP request is coming directly from the browser and not the JavaScript running inside the browser, we get this extra niceness, and we can see all the raw JSON and all these different things. So this is sort of the awesomeness of Django REST framework. And just to do a comparison, of kind of the two approaches. There were extra steps here. I wrote out like things line by line by line, but here's a method to get all Pokemon. On the other hand, here's our API view. And here's the get request, the method to handle a get request, and we can add for post and so on. And it hooks right into the serializer and the response. So hopefully you can see how it, even though maybe it feels a little bit more complex because we're using a class, this is really powerful and really nice. And believe me, as soon as you've written like 5 or 6 of these view functions, you'll appreciate the API view that we get with Django REST framework. So this is really the way that we want to build stuff. And I think what we're going to do shortly is, I apologize, it's not going to be a lot of work time, but we'll break into pairs and at least get a little hands-on time building an API view for our students' application. And to reiterate, the key thing in using an API view is when we tell our routing and URL patterns what to do on this path. With the view function, we could just pass a function. Because this is an API view, we do it a little differently. We call this as view method on the class, and that returns the stuff that our path needs. This actually returns like a function that it uses. So I just want to pause here and see what questions people have or things that it might be useful to go over. How are people feeling about Django API views?
So I need to get some hands-on practice in doing it.
Some hands-on time.
Yeah.
All right. Yeah, let's dive in and do it. And I think what I'll do is, a couple people couldn't be here today and they'll watch the video, but we'll need to do a little bit of review on Monday regardless. I may just shift a little bit of the second part of our lecture into Monday. Also kind of based on your all feedback from yesterday that rushing it really, like the juice isn't worth the squeeze there, because we're sort of building on this with writing more endpoints and seeing how we can write tests and stuff. So let's take, I think the next 30 minutes, and I'm thinking in pairs to make sure that we all get some hands-on time, to look at our assignment for this. And let me actually pull that up. And while I'm doing that, do people generally prefer pairs or groups sort of for the morning work time? I remember we talked about this before. I don't remember where you all landed.
I mean, I'd like to work individually, but I know some people like pairs.
I like the groups because it does let people who want to work together, but then some of the people who prefer individual can do individual.
Got it. All right, I'm gonna assign pairs. If both people in a pair want to group up, please do. I totally get the value of working on stuff individually. I think it is important though to practice collaboration. Let's take, let's work on this for, let's say, 30 minutes and just work on the first part, and then we'll reconvene and look at some other stuff. Let's look at specifically, there's 2 steps to this school API task. This is just describing all of the data that we want to send out. The first task is using what we learned to write an API endpoint for all students. With this format, with the URLs PY in the students app, and using Django REST Framework's API views. Let's just do this first part. If you get to the second part with subjects, great. If not, no worries. So let me go ahead and actually stop or pause the recording and stop sharing my screen. So we're starting to see how to write endpoints and build an API. And how to query, right, and interact with our API. And you all have seen me in the browser. Hit our endpoint that we created with Django REST Framework. There's also a very, very nifty VS Code plugin called Thunder Client. And I'm going to throw this in the Slack, or rather the Zoom chat. And someone please repost this in the Slack so we can reference it later. And it's pretty similar to Postman, but it's in VS Code, which is really nice. And so I can do my queries and test my API from here. And I would highly recommend installing and using this. It makes life a lot easier. And so I can get my Pokemon. Or rather, I could, if I added my port number. And I can get my moves and I can have this in VS Code. So this is a really useful tool. And I would recommend this. And Francisco, thank you for pointing this out. So we're going to keep building on our endpoints and seeing how to do more stuff. For a user to get a specific Pokemon, we need to give them a way to give us that information, right? It's either got to come in the request body or through the URL itself in a URL parameter, looking something like this. And there's two built-in parameters that Django gives us, integer or string. And we've seen that here. Actually, you saw it already. Here, where we use Django's built-in integer type to grab this parameter from a URL, right? If I wanted a string, I could do something like that. So let's go ahead and use this so we can get some specific Pokemon data. So let's look at our Pokemon URLs PY. And here's my path for all Pokemon. And kind of where I want to end up is I want to be able to get information about a specific Pokemon. And I want something, say, like this. And an example would be, API v1 Pokemon ID of 1. However, I don't always necessarily know if the user will use the integer or string in the URL here. And especially with the query string, in addition to just the URL, that can start to matter more. And I want to have some flexibility. And also, I want to show you all how we can write our own converters. So we can have our own types in here beyond just integer and string. So we're going to write an integer to string converter, and we're going to put it into use, and we're going to see it in action. And over here, I want to create a file name converters.py. And we're going to write a class, and we're going to call it int or string converter. And we are going to use a regex. And let's kind of break down what we're doing here with this regex as we're building it. So our regex is going to accept one or more digits, one or more letters, either lowercase or uppercase, right? One letter lowercase, one letter lowercase or uppercase, one or more letter lowercase or uppercase. And that's the regex that we'll use in this class that we're making as a class variable here. And let's write a method here to use as well. And this class method, when spelled correctly, is going to look at the value. If it's a digit, we'll convert it to an integer. Otherwise, we'll convert it to a string. And again, I do want to make sure that I'm not slipping in too many typos.
No, you got the lowercase c with next to the capital A.
Oh, on which line, Clarice?
On line 4, I said that weird. Capital A to lowercase c, I think that might cause a problem. On line 4, my bad.
I think that'll work, but we will see. I think that allows both, like this to be either lowered, all lowercase, or like allows lowercase or uppercase in here. But it is possible I've gotten that wrong. We can see when we get to kind of running this code, we can see what happens. I also want a method for a string representation of the URL. And we'll see how to use this in just a minute. So Django does sort of make use of this because Django is going to work with these methods for this class. And this is going to convert this Python object back to a string representation. And it's called, like, if we have a URL template tag, or sometimes we use a reverse function to convert back to a URL. So Django under the hood uses these methods to convert from URL parameter values and Python objects, right? We're taking in this text data from an HTTP request. We're taking in a parameter value. We're turning it into a Python object, and we're turning a Python object back into a URL. So we're about to use this inter string converter that we wrote, and we're going to use it in URLs PY for our Pokemon. And we can actually put it in here. And I do need to add an import statement, which I'll add in a moment, but we can kind of see where we're going. And so now when a URL matches this pattern of something, Django will decide if we have a digit, it'll convert it into an integer. Otherwise, it leaves it as a string. And then when we need to convert it back, we just give a string representation. But so when a URL gets matched against this pattern, Django will use this inner string converter. It'll call the toPython method that we wrote to convert this data that's coming from the HTTP request, this plain text data, into a Python object and assign it to this variable. And we'll get either an integer or a string as desired. So let's kind of see this in action and see the flexibility that this gives us. So let me go ahead and import my converter now that I've written it. And I do have to use this register command. And Megan, you know, you demoed signals to us yesterday. I 50-50 chance under the hood, Django's register method that we're using here for register converter uses signals, but is implemented with signals, but I'm not sure. But that would be an interesting thing to look into, is how does register converter work and does it use signals? The word register is what got me thinking about that. So here we give it the name. Let me make sure I don't have a typo in just a moment. The name of the class that it will use, and then we give it the name that we're registering it with. Let me make sure that everything looks right here. And let me restart my server to make sure there aren't any other typos or issues floating around. And this is complaining just because I have yet to pass a view function here, which is coming up and which we will do shortly. And it looks like at some point I must have I must have modified my code at some point, folks. I apologize, because we did have the I was using our Pokemon API view and it's floating around somewhere else. So I'll update this code when we circle back to that bit, but I'll get this bit working and then we'll add in the rest.
Someone was moves, Adam. Your
Sorry?
your API view was in views, in moves, not in Pokemon. That's why.
Oh, thank you so much, Paulina. I totally forgot that we that would make perfect sense because we implemented it for the views. And we want to implement we implemented the API view for Pokemon moves, but not for views. And actually that will be a great thing to do now, is to implement all Pokemon and then we can use it here as a view and stick it in. So let's take a quick look at that as well, actually. And I am going to go to moves slash move slash views. And we'll look at all moves. And let's go to Pokemon app slash views. And I'm going to use this as my guide code for all Pokemon. So first, let me make sure I'm importing everything I need. We're going to want to use API view and response from Django REST framework. So let's implement those, or let's import those here. And I am going to copy and paste and reuse this code. This is pretty common in the real world once you're on an existing code base. And you certainly can do this with your own code. You just have to be very deliberate in doing it. So, like, in fact, before I start modifying code, I'm going to read through and walk through all the refactoring changes I need to make. Now that this is a Pokemon API view, I'm going to need to rename this. I'm going to need to use the Pokemon serializer, not the moves serializer. Which then also means I want to change, I don't have to change this variable name, but I want to, so it all makes sense. So let's go ahead and do this step by step. Again, guide code can be great to use. You just have to be deliberate in copying and pasting to understand what needs to be refactored and plan it out, even if it's as quick as what I just did here. So this needs to become a Pokemon serializer. And this needs to become the Pokemon model. And this I don't have to, but I want to rename this so that it makes sense. And now that should be, fingers crossed, a correct Pokemon API view. And we will put it to the test by importing it and using it right here. And actually I'm pretty sure the uppercase here will give me a different name than this all Pokemon method, but just looking at this already makes me a little nervous. So I'm just going to change that name just to make sure that there isn't something, and also to help me kind of keep things clear. And now we've got all Pokemon view. All Pokemon view. Let's see if we can use this here. I'm a little unsure why I'm not getting autocomplete in my VS Code right now. Though this error does seem to indicate why, that API view is not defined. So it looks like I walked through everything I needed to do, but I actually forgot to do my first implementation step of importing our Django REST framework requirements. And this is good. I now have a new error. Your URL pattern has an invalid view. And can anyone remind me, what did I forget to do here that we have to do when we use an API view from Django REST framework as opposed to just a view function that we write ourselves? There's one extra step when we use it in a path. We have to call this method, I believe it is as view. And in fact, let's look at move URLs PY at our guide code here from the move app. And the method name is indeed as view. So when we use an API view, it's a class. We have to call this as view method, and that returns the function that we can then use here in the path. And I do want to give it a name, and we'll call it all Pokemon view, just for simplicity. And so now my server seems to be working, which is great. And we've hooked all this up. There's a couple more steps where we can start doing useful things, like say maybe dealing with an ID instead of a name, which is where this starts to become really useful, so that I can pass in like multiple Pokemon. But let's see where we are right now. Let me go to our Pokemon view. And in fact, this one, I jumped the gun a little bit here. I apologize, because we actually want a specific Pokemon. So let's use it over here and see if it works, and then we can modify it. So we'll come to that, back to that in just a minute. And in fact, what I'm gonna do is use Thunder client and send the request. Um, and it looks like a piece of this is not working. I'm actually going to pop back to the browser because it's a little easier for me to see the error message there. And in fact, may in fact just be a missing slash. And it looks like I may have a typo hiding somewhere because serializer is misspelled here. And we weren't, I'm not sure if we were actually using the Pokemon serializer before. So that is quite possible. And in fact, over here in all Pokemon view is where I have my typo. So let's fix that and see how we do. Let me make sure this is all spelled correctly. And let's see what happens now. Awesome. So sometimes like the Django error messages are actually quite nice in the browser. So I started with Thunder client for the fast feedback loop, but then I went to the browser when I wanted a more detailed error message. And then that helped me see really clearly I had a typo. And now that all Pokemon API view is working and doing what we want. And now we can actually refactor this to get a specific Pokemon so we can make this work. Right. And I jumped the gun a little bit here because we want like an individual specific Pokemon. So let's start by let's actually write our API view for that. Now I could combine this. There's ways to combine API views, but for now, I think writing two separate ones is a bit clearer. So let's see what an API view for an individual Pokemon looks like. I'm just going to call it a Pokemon. It's also going to into API view. Sorry.
It sounded like someone's mic just picked up like Zoom audio for the recording.
Yeah, I think that was a hot mic. So here our get method is going to be a little different because we also want to pass in the ID of the Pokemon that we care about. So let's create an empty Pokemon variable, and then depending on whether we're searching by ID or name, get a specific type. And in fact, let me add a little doc string here saying get Pokemon by ID. ID can be primary key, an integer, or Pokemon name, string. And this is where our converter is going to help us out down the line in handling both of these cases on one endpoint. So if the type of our ID is an integer, then we'll use the awesome Django model querying behavior to get our Pokemon by ID. And this does select, from Pokemon where Pokemon ID equals whatever the ID is what's happening under the hood here. Pokemon objects.get ID equals ID. If it's not an integer, it's got to be a string. right? So either ID is int primary key, or ID is string Pokemon name. So here, we're also going to do a query, but we're going to query by name. And I may have to circle back to make sure I have this ID dot title call correct. But we will come back to that one.
In line 31, you have two T's and objects.
Oh, thank you so much. Perfect. And then finally, once we've gotten our Pokemon, we can return it. And we can use our Pokemon serializer. And for some reason, I'm not getting the autocomplete that I would expect here, but there don't seem to be any errors at the moment. And we'll serialize the Pokemon. And on the Pokemon serializer, we have to access the data attribute property on the class, right? And that has the dictionary that then gets converted into JSON. So now we have an API view to get a specific Pokemon, and we can pass it either the name of the Pokemon or the primary key, basically the ID, right, of the Pokemon. The name is also unique, but is not like formally the primary key. So I think we're almost home. I just need to use my API view in here, and we also need to import it. And then we can see if this works and what we have to debug. And again, because it's an API view, we have to call this as view method. And now I should be able to do API/v1/Pokemon/Pokemon ID. And note, this is part of a REST API too, is this sort of structure of the URL starts with the entity, with the resource, right? With our Pokemon, which we also have a model for, and we also have a table for to store the data. But with the REST API, I talked about entities and attributes and relationships with Postgres. With REST APIs, there's this idea of a resource, and it's the same thing as an entity, this abstract thing that we care about, right? And it's pretty normal that resources map to models that map to tables. But that's sort of the format of these REST APIs is this one gets us all the Pokemon resources. This one gets us a specific Pokemon resource. And if we wanted specific information about a specific Pokemon, we would add, say, moves, right? And this is the structure of a REST API, but we will go into that more later. I think our next step here is simply to see, like, is this working? So let's use Thunder Client first for fast feedback. Let me make sure I didn't break anything. Let me actually kill and restart my server just for sanity. And it does look like something is off. So I'm going to switch to the browser because I get better feedback here. I think it's just the ending slash, because Django does get very persnickety about that. Django like starts looking for a file inside there instead of just, I think. So this is working as expected. I can make my API call and get all the Pokemon. Squirtle has ID 3. Let's try ID 3. So we got an error. Let's do it here and get that same error and see what happens. I may have just missed a slash. I suspect there's just a typo. I'm going to do I'm just quickly gonna check my string as well. And let's pop back over the code and see if indeed that's the case. Even worse than missing a slash, I do indeed have a typo in this line. Any guesses as to what it is?
The closing,
Yeah, the closing angle bracket. And I will say this is the worst kind of typo to have because we don't get an error message that specifically points it out. I did notice something was off in here, and that's kind of what helped me. So this is, I think, a really common gotcha. And there's this term, excuse me. Let me pop back to our URLs. There's this term like magic strings. Like this is sort of a magic string because this isn't really normal string data. This is really structured. In some ways, we'd be better off with this being a dictionary or an instance of a class, because then if I got it wrong, I'd get better editor feedback and the code would break and throw an error. Magic strings, not always the best. So let me kill and restart the server. And let's see what happens now that I've fixed this. Let's see what happens if I pass in an ID of 1. We probably have a new error to work on here. I've got another issue lurking in here. It looks like,
Could you take a look at your project URLs?
yeah, absolutely. Did I totally miss that very first step? Let's go in here.
So in the project URLs, you need that closing slash.
Oh man, that'll do it. Thank you, Francisco.
Of course.
Yeah, that is where I honestly always get a little confused with Django. And yeah, we do need these closing slashes when we're defining these paths. When we're passing them in, Django does not like them so much. Let's see what's going on here.
No, it's just your Pokemon URLs. Seems you have a space. So there's path at nothing. Yeah, you should be able to look it up. You just may need a closing slash up here.
Thank you, sir.
Okay, so it's giving us a 404 not found.
Let's see if I'm getting anything useful in here either. The terminal, less so. API /v1/Pokemon, int or string, ID, name, all Pokemon. I wonder if, hold on one moment, let's try this. Oh, I see you highlighting something over there.
Yeah, so I was highlighting the fact that it's not finding the URL, right? So it's
on line 13, does it matter that the name is all Pokemon view instead of a Pokemon?
I wouldn't think so.
no, I don't think it matters. Oh,
Yeah.
you do have those paths backwards though, Adam.
Oh, which path is backwards?
Is line 16 should be above line 13. Otherwise, you're gonna get some errors.
Got it. Let's see what happens here. Let me get rid of this trailing slash as well, because I think the trailing slash is not what it wants. Like, oh, though errors doesn't really matter with the trailing slash. I apologize. Yeah, the name shouldn't matter because we're not using the name for either of these. So something is going wrong between line 13, which works fine, and line 14, which totally breaks.
Would it be easier to hard code the ID to see if the Pokemon as view works? And
Uh,
then converter?
Yeah, I like that idea. Though it won't
grab the parameter though.
grab it, but let's do it like this. Let's simplify and see if that does anything. I suspect we'll have the same issue. Okay, so that actually works great. So that was a great idea. Thank you. So that's how, yeah, great idea. Great simplification. That tells us that this part of the path is working. It tells us that my API view is working. As long as we're doing this, let's see if this works. Well, let's not get ahead of ourselves. We did Pikachu. Let's do another Pokemon. I think maybe Squirtle was in there as ID 3.
Closing slash, yeah.
Thank you. So Squirtle works. Let's try this as a string with Pikachu really quick. We might as well just, while we've got this bit working, test that our conversion is working in there, and then we can figure out what's wrong with the path stuff. So there's an issue there that we'll have to tackle because I do have 2 Pikachu, and I can actually tackle that one relatively quickly. Because we can use the first argument over in here, and we can do get, and we can do, I believe, dot first. And
I think the problem's coming back from the get function. The get function can only return one value from the query. So if it's finding multiple, it's going to return an error.
Yeah, you're absolutely right. So that our code is actually behaving correctly there. This is actually an issue of bad data. We're really, I need to put a uniqueness constraint on the Pikachu name on our model.
You can do filter dot first.
Do what dot first?
Dot filter instead of dot get, and then after that dot first.
Oh, that's true. Well, we have Squirtle in there as well, so we can test that this is handling that this part is working great. This a Pokemon get works both for integers and strings. And the refactoring to handle if somehow we have multiple, to avoid the multiple Pokemon name problem, we can tackle later. So this is really good, and this takes us to I just have something here, maybe in the naming of this or the use of register converter or in the converter itself that is not right. And if we can knock it out in the next couple minutes, we will. Otherwise, we may need to pause and wrap, because it is approaching 1. And while unfortunately, I would love to look at testing, but I think that one I may have to give to you all as assigned reading over the weekend. And the good news there is I think like once we've seen at least how to build this, like walking through the tests is a lot easier. If we can maybe get to 1 test, that would be great. But we'll see. So let's see if we can quickly spot what's going on here. Otherwise, we'll move on. Though the irony is, in some ways, writing the tests probably would help us catch this error. But let's take a moment just to see if we can't catch what's happening.
Maybe in converters.py.
Yeah. Let's take a broader view here. So we have a toPython method. And we have a toURL method. And
on your line 10, wouldn't you need a return statement before that string from your
Sure.
converters.py?
Good catch.
Say that again.
In your converters.py on line 10, wouldn't you want to return that string value?
Yes,
And probably again in the defined URL to return that string value as well.
you are absolutely right. That is my bad. And I will say, yeah, thank you so much, Megan. That very good chance that this is the problem. And let's see what happens here when we do this. That was definitely a problem. Now we do seem to be hitting another one. I have a feeling like I'm doing something wrong with registering the converter because this, we keep,
Is it anything, does the regex need an or symbol between 0 through 9 and A through Z?
It does.
Yeah, it does.
what is the or symbol? Oh.
So you're saying it's a digit, or it should be digits or, yeah.
Let's
Then
see
you
what-
should probably look at your main URL file.
Oh my God.
Oh, there you go.
There we go, folks. Great. Halsey, was that yourself? Am I recognizing your voice correctly?
Yeah, I also followed along in the notes. I thought it looked a little bit different and I was writing it too and
You're
found
totally
it.
right. Great. Yeah, thank you very much, folks. So unintended, but there's two lessons we're taking away from this. Because now we do appear to be working. We've got Squirtle, we've got ID3, which is awesome. Because if I'm writing a React app, I will really appreciate an API endpoint like this that gives me this kind of flexibility. So the two takeaways here are, well, three. First, awesome debugging job, everyone. Thank you. Second, sometimes the error messages are not exactly reflecting the problem because like the failure is cascading. And so Django could only tell us, hey, we have a problem with this path, but we were able to narrow it down. And note that like the simplification step really helped us there because we got to very quickly isolate where the problem code was. And the third one is, I should have just written a unit test for this right off the bat, and we would have caught this early and avoided this altogether. And I think that is probably a good point to touch on to wrap up. And I do, I don't want to, I apologize because it is getting close to 1. And I do feel like the testing will have to be saved for another day, but I do think this is where unit tests can help us a lot. This is a great example of something to write a unit test for, and that would help us a lot. And then we sort of walk through building tests for all the different parts of this endpoint. And it's really valuable too for like refactoring our code. So I do want to wrap up here. And I would please encourage everyone, please do take a look at the testing parts of this lecture. Yeah, and thank you all for your help in debugging this and getting this working. Kind of before we wrap for the day, do folks have any questions about API views? Right, to kind of recap our API view journey, and the journey of everything with routing and API views. And now I can also use Thunder Client and get data, which is great. From the top, today we have seen how in URLs PY for our Django project, we can include the URLs PY from an app. And then in the URLs PY for one of our Django apps, we can add the routes specific to our API. We've learned the very foundational rules of designing a REST API to start with API/v1 and the name of the resource. And then when you want a specific resource, how to add that in. We reviewed and seen how to grab information from the URL and pass it into our view functions, how to write a custom converter, and most of all, we've seen how we can use Django API views to combine our models and our serializers to construct the JSON that we want our REST API to return that we're then going to use in our React application. So this is really cool. So this is the full path. I do apologize that we're not able to get to writing tests, and I do want you all to take an hour, not today, but over the weekend, to go through that second part of that lecture and code along with it to build those tests. And you'll see, we have tests and we have solution branches on the assignments that you can look at as well as reference. And on Monday, we're going to start adding more on, and like next week, we're going to start looking at the full stack with some React stuff as well. But I definitely at least can look in on chat with people who have questions about tests, and maybe the TAs can do a breakout session or something as well. So I just want to see what questions folks have about whether it's these routes or API views or this really cool converter that we've seen how to implement for our paths and our routing. Okay, awesome. Folks, thank you very much. Let me stop our recording.